All right, so our next station is multiplying and dividing rational expressions. And the main thing I'm going to remind you is, and this is the saying I use, don't forget to copy, dot, flop when it's a division problem. So this does have a few more problems, but some of them are a little simpler. So let's just take a look at number, let's see, which one do we want to start with? Let's start with 3. That's a good multiplication problem, and then we'll pick a division problem. So I tried to keep the factoring here not as bad as the others since there's a few more problems. All right, so starting with number 3. So when I look at my first fraction, what I'll want to do is just like you do in the simplifying, I'm going to want to try to factor every numerator and every denominator. So when I start with n plus 5, I cannot factor that. So I'm going to leave that one alone. When I look at 8, I could factor 8 down into all those basic numbers, but I'm not going to worry about that right now. So my first fraction will stay as n plus 5 over 8. My second fraction, though, I'm going to factor. So the first thing I'm going to look for is a GCF, which this one doesn't. So I'm going to make my x for the numerator. And I need factors of negative 40 that get me to 3. And that's going to be an 8 with a negative 5. And now I can go to my parentheses, drop some n's in. And n times n is all I need to get to n squared. And now following a loop, which I'm going to make invisible, n times what makes positive 8? And that would be an 8. And then a loop here would be n times what makes negative 5n, and that would be a negative 5. So now that I'm done, I'll just double check. Is there a difference of squares? This is not a difference of squares, and this is not either. So now for my denominator, there's not a GCF, but this is a difference of squares. And this will factor into n plus 5 and n minus 5. So when I'm done now, I'm going to wrap this one in parentheses just to remind myself that it's protected. And I'm going to find the common factors between the numerator and the denominator. So I can take an n minus 5 from both and an n plus 5 from both. What I cannot do is take this 8 out. This 8 is a term. It's not a factor. So the parentheses are protecting it. So when we're done, the only thing left in your numerator is n plus 8, and the denominator is 8. And that is number 3. Now, as far as, let's do number 5. So number 5 is a division problem. So I will copy this one. As I copy it, I will be copying it into factored form. And I'll dot and I'll flip-flop this one. And when I flip it, or flop it, whatever you want to call it, I'll be doing a GCF. Anyway, so starting with this numerator, the first thing I look for all factoring, so I'm just going to put a little red dot here, is a GCF. I do see that I can take a 2 out. So I'm going to take that 2 out. And then from here, I'm going to make my x. And I need factors of 6 that get me to 5. And that would be a 2x and a 3x. So I'm going to start my factoring work here. So here goes my GCF of 2. Here go my parentheses for this. And when I drop those x's in, x times x is not enough. I need this 2x squared, so I will have to put a 2 with one of them. And now I'm going to have these loops here, very light, to make these numbers. Again, x is the most easygoing. X can make both of these, so 2 will have to work first. And 2 can only make this 2x, so 2x times what makes 2x? That's a positive 1. And then x times what makes 3x? And that's a positive 3. So the numerator is factored. Now I'm going to go to my denominator. First thing I'm going to look for is a GCF, which this does not have, so I'll just go straight to my x. I need factors of negative 12 that get me to 4, and that would be a 2 and 6, with 2 being negative. And I'm going to go straight to my parentheses. I'm going to go ahead and drop those x's in, but realize x times x isn't enough. I need not x squared, I need 4x squared. So with 4x squared, you'll have to realize that 1 and 4 can get you there, and 2 and 2 can also get you to this 4x squared. And we're not going to end up using the 1 and 4, because while 1 can make these numbers, 4 can't make either one. But 2 can make this number, and the other 2 can make this number. So I'm going to drop 2's in there. You can do those loops to get these side numbers. And since they're both 2, I'll just let this 2 get this number and let this 2 get this number. So 2 times what? Because I already have the x. So 2 times what makes -2? That's a -1. And then with this, 2 times what makes the 6? That would be a +3. So my first fraction has been factored, but it's division, so I just copied in factored form. Now I'm going to dot, and now I'm going to flip-flop this one. So this numerator is about to become this denominator, and when I look at it, I see a GCF of 6, so I'm going to take that 6 out, and I'm just left with x plus 1, and can't factor that anymore. In fact, any of these, I can't factor anymore. None of those are a difference of squares. And now this denominator is about to become the numerator, and there's a GCF of a 2, so I'm going to take the 2 out, and then I'm left with 2x minus 1. And now I'm going to look for my common factors. So the first common factor I see is this 2x plus 3 in the top and a 2x plus 3 in the bottom. And then I see an x plus 1 in the top and an x plus 1 in the bottom. And then I also notice a 2x minus 1 and a 2x minus 1. So when I'm done, I'm actually just left with a 2 and a 2 in the numerator and a 6 in the denominator, which, you know, just to show you what I did the other day, I'm not going to multiply those 2's, but I am going to break the 6 down into 2 times 3, and then I can take a 2 out and get 2/3, and then that is all you're left with on 5. So from there, your job is to do the rest, okay? I feel like there are going to be questions on 1 and 2, so to beat those questions, this is pretty simple. The way we did this is we would have made these houses, if you remember, and we would have put 19 in a house, 15 in a house, 9 in a house, 17 in a house, and then the B's in a house. And what I'm going to do here, just to kind of keep this idea of factors of 19, I can't factor anymore. 15, I can factor into 5 and 3, and then you can't factor that anymore. 9, I can break into 3 and 3, and then 17, I can't do anything with as well. And now I have a common factor of 3 that can go out. And so as far as this answer is concerned, since this is pretty basic as far as numbers go, I'll go ahead and just take my calculator and do 19 times 5 for my numerator and get 95 and the 17 in the bottom. And as far as this goes, if you remember, this says there's 3 b's on top multiplying and 1 b in the bottom, and I can take out one of those b's, so I'm just left with 2 b's on the top. And that's the same idea as number 1. So there you go. You've seen a little bit of everything, and that's it. So get going.